All right, looking at number 110, no calculator, integrate. So A says 3e to the 4x plus 2 to the x dx. Anytime we've got the plus sign, we want to make it two integrals. I know it looks convenient to keep it one. It's a lot smarter to do it as two. Just doing two separate problems. Anytime a derivative would have given us a chain rule, we should be in the habit of trying a u substitution. So u is for x, then du is 4, which means I've got an extra 4 here. So I'm going to put that, take care of that right there. I'm also going to put the 3 out there as well. Remember that 3 is just a constant. So I've got 3/4, the integral of e to the u. The integral of e to the u is e to the u, so 3/4 e to the u plus that c. The antiderivative of 2 to the x is 1 over natural log of 2 times 2 to the x plus c. So now let's just put them back together with resubstituting in the u of 4x. So 3/4 e to the 4x plus 1 over the natural log of 2 to the x. And then we combine c1 and c2, we get c. Good answer there. And let's take a look at B.
Okay, Mr. Richard.
All right. The integral from 0 to pi of sine cubed x cosine x. So we've got to do a u on this one. Which one's the furthest inside? We've got something being cubed. So if u is sine x, then du is cosine x. Now let's also do our limits. If I put a 0 in here, the sine of 0 is 0. If I put my pi in here and change my bounds, the sine of pi is also 0 of u cubed du. What's the area of something from 0 to 0? 0. So that's like a convenient, if we did the correct substitutions there, we should know that's actually going to end up being 0. And go ahead and try to graph it and look at what this looks like from 0 to pi. You should probably see it's going to cancel itself out and become 0. All right, let's look at C. The integral of x squared, 3x cubed plus 5 to the 4th dx. My furthest inside has got to be something to the 4th power. So u is 3x cubed plus 5. My derivative of that guy is 9x squared. So I've got an extra 9 here, so I've got to put a 1/9 outside. So 1/9 of u to the 4th du. 1/9 u to the 5th over 5 plus c. Put my u back in, multiply those guys. I'll probably put it as 3x cubed plus 5 to the 5th power divided by 45 plus c. Let's try the next one. The integral of 5x to the 0.25 over 4x to the 1.25 minus 6 dx. That minus 6 is outside. So we can't have a u be in the top and a du be down here. So let's try this whole thing as our u. (1.25 minus 6) du is 1.25 times 4 would be 5x to the 0.25. That ends up being quite convenient. And then that 6 goes away. So really we're left with 1 over u du, which is always our convenient integral. So the integral of 1 over u is the natural log of u plus c. Go ahead and plug this guy back in. Natural log of that plus c. Great. And let's do e. E to e cubed 1 over x natural log x dx. So we've got kind of two options. U could be 1 over x, or u could be the natural log of x. If we know our derivatives, we know that the derivative of the natural log is this guy. So u is the natural log of x, du is 1 over x, which is, again, quite convenient. Let's go ahead and put these guys in. The natural log of e is 1. The natural log of e cubed is 3. So then we've just got u du, u squared over 2. So let's go ahead from 1 to 3. So we've got 9 halves minus 1 half. Our answer should actually be 4. Let's do one more. The integral from 0 to 1 of 1 over 1 minus x squared. Now, we gotta start seeing this as the sine inverse of x from 0 to 1. So the sine inverse of 1 minus the sine inverse of 0. Sine inverse of 1 should give me pi over 2. Sine inverse of 0 should give me 0. Pi over 2. No u substitution necessary. Go calc.